Hello everyone, in the previous video I showed how to do the animation offset for Melee provided by Miss Holly on Discord. However, to add even more combat flow, I wanted to add a dodge roll system. So I wanted to talk to everyone about how they can do that by copying my blueprints. You can adjust it to your liking, but this is kind of how I did it. However, I did have to purchase a Rolls and Dodges animation kit. You can purchase it as well. I'll leave the link in the description. But I'm no advocate for them. I just am not an animator. So if you have your own animations or you want to get something from somewhere else, you're more than welcome to. So start off, we need to first make sure that we have an input to use as a key for it. This also helps so when they want to, in the kit you can adjust or switch your keys that control things. So this, we want to make sure we keep up with that so the player can set their own keys. So what you're going to do is you want to go, one second, project settings. From here, you're going to scroll down until you see input. The input is where all the keys in the engine are. For example, you can see, the pop-up, which is when you hit space when swimming, the building modifier, your hotbars, etc. So you're going to do is you're going to add another key action input and name it, for example, for this tutorial, we're going to do dodge roll, and I made it the left control. I then switched the dive to the C key. I wanted the dodge roll to be something that is near your sprint key as well. So once you have that, then you're good to go from that point. Next, you're going to want to navigate to the BPI. This is where the network code can begin. Sorry, I blinked out for a second. Easy way to find it is to go into your BP character player blueprint. And on the event graph, you'll see, where is it? Set movement speed, no. Event should sprint, BPI. Just double click this and this will go find BPI character. You can also search for BPI character if that's something you choose. What you're going to want to do in here is you are going to add a new function and you are going to call it set should dodge roll underscore BPI. You are then going to set the category to state, and from there you're going to add the input as a boolean. When you hit plus right here, new parameter, you should do should dodge roll and set it to a boolean. You're going to save and compile. And this will give it so that the server can handle this interaction. This will allow it so that other people can see when your character dodge rolls. So using the set should sprint BPI logic, you're going to call should dodge roll. Don't use event, actually type in should dodge roll, and you're going to see it called BPI. Cool. Put that in. You should see your boolean right here. Then you're going to make a new custom event called set should dodge roll parentheses server. From here, you're going to go into the settings and select run on server. You want this to run on server so that people can't exploit this dodge roll. And you want it to be reliable because it is an input, so you want it to always happen. Your input, again, you're going to create should dodge roll with a boolean. This is to keep the nomenclature the same so that you don't really get confused when you create other aspects. So then from here, you're going to promote to a variable, and you're going to set a variable called should dodge roll. It's not going to be initially with these two actors. This means it's replicated. So what you're going to do is click onto this after you set it and make sure that it's in the state interactions category and that you have selected replication for it. Otherwise, it won't work on the server. So once you have that set up, you can come back to here to initialize dodge roll and then call this function you just created. and you're going to call set should dodge roll. So this has been set up. So now we need to actually make the input happen. We need to, when you hit the keyboard, something happens. So what you're going to do is search for inputs in the same character blueprint. You can see sprint and fast swim. Here, I went ahead and called the input action dodge roll. So you can type in dodge roll if that's what you named it, and you'll see input actions events dodge roll. You're going to bring it here. And then you're going to call that function twice. Once you press it and once you release it. Basically, the logic here is once pressed, I'm dodge rolling. Once released, I'm not dodge rolling. So you're going to set should dodge roll. However, how do you make it do something? You need to actually make it do something from this point. So what you're going to go do is create a new function. I suggest you could just duplicate the check sprint function. That's kind of exactly what I did to make this logic. So if you do check sprint, you can duplicate it. Once you duplicate it, you can name it check dodge roll. So within here, you are going to set this check dodge roll to be part of state and make it public. Again, so the server can access it and everybody can see it. And it's called check dodge roll. Make sure it has a switch authority, so only those who are authorized to do it can do it. You're going to call your variable from before called should dodge roll. So essentially this is calling your input, true, are they pushing this button, or false, are they not pushing this button. So once there, we want to check, we're going to create a branch statement. We want to check to see if they're doing, a different action. I think I messed that up a little bit. This should probably be plugged into there, but it doesn't matter. It still works. I need to clean this up for less redundant code. But anyways, so we're checking if there's another action. This should be here, but that's fine. It's whatever. So actually, we have to create a new variable called isDodging. We have to create a new variable called isDodging. And here, if nothing's happening, we're going to set isDodging to false, like you're not dodging. So replication, we need it replicated, and we also need it to be in state interactions. That's for organization purposes. So we have a should dodge roll and an isDodging. Should dodge roll is based upon the input, and isDodging is tracking within this check. So you need the two different booleans. So if another action's not happening, we're not dodging. We have the capacity to dodge through should dodge roll, but since it's not set, we're not dodging. So you don't want a dodge roll to happen if you're swimming. That would be weird. So you want to make sure that you check to see if you're swimming. So we're going to create another branch to check to see if we're swimming. So we're going to get a character movement, is swimming, return it. True, if they are swimming, we want to say no, they're not dodging. They can't dodge, they're swimming. And if false, then yeah, they can dodge, they're not swimming. So on the false, we want to make sure we check to see if they're in midair. If they're falling, we don't want them to dodge roll either. That would also be weird. I mean, you can if you want, but so if they're falling, which you're going to do character movement again, is falling, if it's true, you're also going to say no, they're not dodging. But if it's false, you're going to set is dodging. This is from this code. This essentially is borrowed from Sprint. It just makes sure that if they're blocking, they can't dodge. If they're aiming with a gun, they can't dodge. I kept it because I felt like it was valuable. If you're overloaded with weight, you don't want to dodge. So from here, you're going to keep this code from the Sprint. Next, we're also going to take the code that was originally from the Sprint and move it up into this position. So they essentially had code in here to already check direction, so that's perfect. We're going to reuse because as an efficient kit user, you always take the code they have provided and manipulate it. So essentially, you're going to get the velocity of target actor. You're going to form an X vector, rotation form X vector, and then you're also going to get the actor rotation plug those two into the data rotator, and on the Y, you are going to promote to a variable, but to a local variable, and call it local direction. You don't have to set it to any value. Leave it at 0, 0. This is mainly just to track your character's position. It's just going to be constantly updated. From here, you're going to plug in the isDodging into this set. So you're setting the local direction based upon this information. And then you're also, from the output, going to create this branch. However, before that happens, there's a condition. We need to make sure that it's within range of certain directional degrees. So for instance, right here, we're checking, if you think of a pie graph, we're checking from negative 120 to 120, which is the forward direction. So we're checking the forward direction. Are you moving forward? Because what we're going to check is to change the animations based upon if they're moving forward or if they're moving backward. So if the character is moving forward, true, then we're going to do these 3 sets of animations. If the character is moving backwards, then we're going to do these 3 sets of animations. So for example, we're going to go through the logic of if the character is moving forward. So, true. Character is moving forward. However, are they moving directly forward between negative 30 degrees and 30 degrees? If so, then we are going to apply moving directly forward. Yeah. So true. We're going to make a branch. However, we're going to add a new condition. We're going to call energy. This is how your character player has energy, and we are going to add it to a float comparison of greater than. Is energy greater than 9.9? If so, then we can change the energy to the roll energy usage, which I have negative 10. What this is doing is actually costing energy when the player is dodging. And this is checking to make sure you have enough energy to even basically cast or press the input. If you're able to do that, then we're going to call play animation multicast. So play animation multicast. From here, what we're going to do is break this struct. So you're going to split this struct pin. Oh my God. So once you split the struct pin, you're going to see multiple values within here. You can set it to whatever you want, but for this instance, I have the test roll forward animation, and that's what I put for this animation. And due to the logic of spending energy, we want to make sure that as soon as this animation is complete, that we set should dodge roll to false, so that they stop spending energy. So it's not an infinite loop per se. So that's for the forward direction. The same logic can be applied to any other direction. So if it's not between these degrees, is the player facing towards forward left? If so, then we are going to do the same exact logic and play the forward left animation. If they're not, are they facing forward right? If so, we're going to do the same exact logic and do the forward right animation. Now going back to the original, okay, they're not facing forward. So how do we do this logic? Are they between the back right, or back left, excuse me? If so, we're going to play the back left step back animation. If they aren't facing that direction, we're going to do the back right step back animation. And if not, then they're obviously moving directly backwards, and we're going to apply this. So that is essentially everything you need to know for this, except one last part is we have to call upon the update tick. This is where it's constantly checking the character state. I recommend putting the check dodge roll after sprinting. So you would just call your check dodge roll function, put it within here, and you are good to go. Showing a demonstration. forward, right, left, back, back left, back right, or back right, back left. I said it in the wrong order, but you get the idea. So now it's spending energy as well as intended. Hopefully you guys enjoyed this tutorial. It's a little rough. It's my first one, but it should get the job done for you.